So here's 8.3. Our objective is we want to be able to understand and use series and something called sigma notation. Now, you probably haven't seen something like this before. Mason probably has. But we just want to write the next two terms in each one of these sequences. So do not say anything out loud. I just want you to look at them and think about what would be the next two terms in those sequences. So, Andy, help me out on A.
10 and 12.
10 and 12. Not too bad.
Oh, 2.
Dane, help me out on B.
I got 16 and 32.
16 and 32. Perfect. Little bit tougher on this one. Zach.
3 30-seconds and then 3 60-fourths.
3 30-seconds and then 3 60-fourths. The tough part about this one is it's the denominator that changes. The numerator just gets to stay the same. Okay? And then somebody help us out on D. How about D?
Yeah. 16 and 12.
16 and 12. Okay? Now, you may recognize those, so let's talk about what those are. Those are sequences, and sequences are just lists of numbers, and the two most common sequences are arithmetic and geometric. You studied those last year. A sequence, if it's arithmetic, that list of numbers has something called a common difference. So it has a common difference between any two pairs of terms. And a sequence is geometric if the list has a common ratio. So the big difference here is, you could think of it this way. We're adding and subtracting to go from one to the next if it's arithmetic or if it's arithmetic. We're multiplying, and we always think of it as multiplying when we're doing geometric ones. Okay, we don't think of it as division, even if it is getting smaller and stuff like that. So arithmetic is going to have a common difference, a positive difference if they're getting bigger, a negative difference if they're getting smaller, if we end up subtracting, if you want to think of it that way. And if it's geometric, the ratio is bigger than 1 if it's getting bigger. The ratio is smaller than 1 if the numbers are getting smaller. Okay? And a quick reminder. Okay, these are called the explicit formulas, and these are the ones that you would see in a textbook when you go to college if you take 1050 or something like that. For arithmetic, it looks like this. A sub n, that means the nth term, is the first term. That's what a sub 1 represents, plus n minus 1 common differences. So this is the first term, this is the common difference, and n is just the index. It's the counter. It tells you which one that you're on. Okay, and recall that in order to find the common difference, you can take any term, so take a look at this, you can take the nth term and then subtract the one before it, okay? So if this was a 5, this would be 5 minus 1, so that would be 4. If you want to find the common difference, you subtract the 4th term from the 5th term, okay? And similar type of thing for geometric, the formula is a sub n, so the nth one in whatever your sequence list is, it's the first one times n minus 1 common ratios. And a lot of times we'll put that in parentheses so that if the ratio happens to be negative, everybody gets things that's squared and cubed and whatever, we raise it to the right power. And then we want to remember that in order to find the ratio, you can take any term. So if you take the nth one, which is what this is talking about, you can divide it by the one before it. So you can tell whether or not you've got arithmetic just by checking to see if you've got a common difference or a common ratio. So we're going to do something that you haven't seen in a while, but is a really good skill. We're going to take these sequences and we're going to come up with the formula for each one of those. And we're going to use these general formulas up here. And just as a reminder, you can call it an explicit formula, but you will hear some people call it a general formula or an nth term formula. Those are used interchangeably. We used those last year in secondary 1. So here's the deal on this one. You might recognize this. This is the one from up above. We've got 2, we've got 4, we've got 6, we've got 8. If you take any term, like let's say I take 6, and I subtract the one before it, I get a 2. The difference between any one of these is 2, so I'm going to write d equals 2. And I'm going to shrink this down just a little bit, or blow this up just a little bit so we can see. And we want to find the explicit formula for this. So the formula is going to be the nth one is the first one plus n minus 1, and that's in parentheses, common differences. So in this particular case, A sub n is going to be the first one, which is 2, plus n minus 1 common differences, which also happens to be 2. And then we normally simplify these. We don't leave it in that format. So I'm going to distribute through, and I get 2 plus 2n minus 2. I can cancel the two of those. So that means the nth term formula, the general formula, the explicit formula is just this, 2n. Put a box around that and I'm done. Yeah.
Isn't there some alternate formula where it's like a sub n or a sub n equals a sub 0 times?
There is, but you won't find that in a textbook. You won't find that.
Why not?
Okay, because it uses the 0th term, and there's usually not a 0th term. Okay.
Wasn't just the term before 2?
Yeah, it
So
is.
it's just 0.
Yeah, you can, if you want to use that one, that's fine. I'm just telling you, you're not going to see that in a textbook, and you're not going to have a teacher that says, oh yeah, that's the formula that I use. Okay, just doesn't happen. So this is the formula. You can double check and make sure that that makes sense, because the fourth one is 8. If you plug in a 4 here, a sub 4 equals 2 times 4, so we end up with 8. That checks out. It's the right one. As long as we're careful about how we simplify, then we're in great shape. If we take a look at the next one, this one we're multiplying by 2 every time. We ought to maybe double check and make sure what the ratio is. So I'm going to take 8, the third one, and divide it by the second one, which is 4, so I end up with 2. So the common ratio on this one is 2. So here's the formula. A sub n is going to be the first one plus the common ratio raised to the n minus 1. So on this particular problem, it's a sub n. This is 2. The common ratio also happens to be 2, and we raise that to the n minus 1. Now, some people, when it's exponential, they will leave it like that. I wouldn't. There's some good practice and some good exponential skills that we can realize and kind of bring to the forefront if we simplify this. So here's what we're going to do. I'm going to take this and I'm going to write that 2 right there. Then I'm going to write 2 to the n. And then I'm going to write times 2 to the negative 1. What I've done here is I've broken this into 2 pieces. Okay, remember that rule that says if I have x squared times x to the third, I can add those together?
Yes.
Well, if I were to write the step in between, if I've got x to the 2 plus 3, I could write it as x to the second times x to the third, and that's what I've done here. I have 2 to the n minus 1. I've got 2 terms here, so let's just break it up so that we've got 2 factors there. And then I can do some simplification. Dane, do you remember what a negative in the exponent means?
Reciprocal.
Reciprocal. So this is 2 times 2 to the n times 1/2. And I can cancel that 2 with that 2. You wouldn't want to mess with the exponential at all. So the only thing left on this one is a sub n. The nth term is just 2 to the n. These are 2 really, really simple sequences. One's arithmetic. The first one's arithmetic. The second one's geometric. Okay, any questions there? Why is it so hard?
Yeah, it's a lot for like a small answer.
That is. Okay, let's take a lock at the next one. Don't say anything out loud. Look at this and figure out, is this arithmetic or geometric? Don't say anything out loud. Caleb, what do you think? Arithmetic or geometric?
Geometric.
Geometric. Can you tell us what the common ratio is?
1/2.
It is 1/2. How did you figure out that it's 1/2?
Because the first one's 3/4 and the next one's 3/8. So like the first one times 1/2 is the next one.
Okay, so we figured it out that way. If you're not sure, let's say you were looking at it and thinking, I think it's geometric, but I'm not sure and I can't really figure out what the common ratio is. Take any term and divide it by the one before it. So I'm going to take the second one, which is 3/8, and I'm going to divide it by the one before it, which is 3/4. We never divide fractions. We're always going to flip this over and multiply by the reciprocal, so this is 4/3. So this is a 1 on the top and a 2 on the bottom. So this is geometric and the common ratio is 1/2. So again, the formula, and I would get these memorized if I were you, it's a sub n is equal to, so the nth one is equal to the first one times n minus 1 common ratios. So the first one here is 3/4. The common ratio is 1/2. raised to the n minus 1. And then in order to simplify this using the properties of exponents, we're going to write 3/4, we're going to write 1/2 to the n, and we're going to write 1/2 to the negative 1. I'm going to ask Samara. Samara, what does a negative in the exponent mean?
I have no clue because, oh wait, there's the I thingy. No, I don't know
What?
anymore.
Okay. Megan, what does a negative in the exponent mean?
Reciprocal.
Means reciprocal. So here's what we're going to do. We're going to take this and we're going to flip it over. So we've got 3/4, we've got 1/2 raised to the n, and if I flip that over, I have a 2/1.
Oh, that's 2.
I can cancel the 2 with the 4, so that's a 2. So here's the nth term formula for this. It's going to be 3/2 and then 1/2 raised to the n. And if you wanted to double check and make sure that that gives you the right terms, if you plug in a 1, let's see if this makes the right first term. Plug in a 1. That's 1/2 to the first, so that's just 1/2. 3 times 1 on the top would be a 3. 2 times 2 on the bottom would be a 4. The first term is 3/4. This does produce the right sequence.
Wow.
What?
Plug in a
Is this one arithmetic?
Okay, let's do the next one.
I'm ready.
Psi, arithmetic or geometric?
Arithmetic.
Arithmetic. Can you tell me what the common difference is? Common difference is 4. Anybody want to amend that just a tiny bit? -4. Thank you very much. I'm going to freeze the screen after I write this down. You've got it up above, but when we're doing arithmetic, it's the first one plus n minus 1 common differences. I'm going to freeze the screen. Would you find the general formula for that, the explicit formula, the nth term formula? Make sure that it's simplified.
Yeah, I do. I didn't.
Okay, raise your hand if you're done. Okay.
I like arithmetic more than geometric.
You talk slow. Crew, what'd you get?
32 minus 4n.
How many of you wrote 32 minus 4n? How many of you wrote something slightly different than 32 minus 4n? Okay,
Silly gooses.
all right.
Oh.
We normally write the variable term first. Doesn't matter. If you wrote the 32 minus 4n, that's totally fine. This is just by convention. This is the right answer. Raise your hand if you got the right answer. All right, excellent. Okay. All right, now we're going to talk about something called a series. So would you put a star right here? A couple years from now, you're probably going to be taking calculus, and you're going to do series a whole bunch. This is what people struggle with when they get in calculus. Okay, so we want to make sure that we've built a bit of a solid foundation for this. Okay, basically it's just a sequence with pluses and minuses in it. Okay, we take all the terms and we just add them together. All right, so we have what are called finite series. Those would stop, and we have infinite series. And those, of course, would keep going on forever. So if we take a look at this one right here, it says we just want to label this as infinite or finite. So this one right here, crew,
Finite.
that one is finite. Can you tell us how you know?
Because there's not 3 little dots after it.
Does anybody know what the 3 little dots are called? Yep,
Ellipses?
it's called an ellipses. Okay, so this one right here would be infinite. And this one right here would also be infinite. Now, would you label each one of those as arithmetic or geometric? So this is a finite series, but is it an arithmetic series or is it a geometric series? Colson, what do you think?
Arithmetic.
It is arithmetic. Can you tell us what the common difference is? D equals 2. Okay? Hannah, next one. Arithmetic or geometric? It is arithmetic. Can you tell us what the common difference is? Common difference is 1. It's getting bigger by 1 every single time. And then this next one is infinite. So, Andy, geometric?
Yeah,
Arithmetic? Geometric? What's the common ratio?
2.
Common ratio happens to be 2. Okay? Now, it's kind of a pain in write these what are called expanded form. This is expanded form. The ones that we just did, those 3, they're written in expanded form. Luckily, we don't have to write things out all the time like that. We can thank the Greek letter sigma for helping us out with that. The Greek letter sigma looks like this. Mine are horrible. This is the best one that I will draw. I'll draw one for you, but it looks about like that. That's the capital Greek letter S. S for sum, and here's how we work this. Okay, there's an index. Stop talking, please. There's an index. Usually it's K, but we can use any letter we want. If you want to use N, if you wanted to use X, that would be okay. This is the lower limit. So K is the index. That tells us what variable we're using in the little formulas. Okay, we're going to start usually at 1, but not always, and it always goes up by 1. That's the lower limit. We start by plugging in a 1 in this particular case. Then it's going to go up to whatever this is. That's called the upper limit. So we stop once we've plugged that number in. So we start at 1, count by 1 until we get up to whatever that number is. And this is the explicit formula in here. Again, it's normally given to us, but not always. There are times where we're given something like we had up above, and we actually have to figure out what the formula is so we can write that in sigma notation. Okay? So we're going to take a look at this and we're going to see what this looks like. So we're going to do a couple of these. These are written using sigma notation, and we're going to write them in expanded form. So I'm going to start by plugging in a 1. So if I plug in a 1, I have 2 times 1, and then I subtract 1. So I'm starting by plugging in a 1, then I'm going to plug in a 2, then I'm going to plug in a 3, a 4, and a 5, and then I'm going to be done. So this is 2 times 1 is 2, minus 1, so this first one's going to be 1. If I plug in a 2, I've got 2 times 2 minus 1, so that one's going to be a 3, and I put a plus in between them. So then I plug in a 3, 2 times 3 minus 1, that's going to be 5. Put a plus in between them. This next one's going to be a 7, and that last one's going to be a 9. So this is in expanded form right there. This is sigma notation. That's expanded form, and if you take a look, it's actually that one right there. So if you were to write this one in sigma notation, it would look like this. Dane.
What's the top number?
The
That's where it
5,
stops.
that's where you stop. That tells you where you stop.
Why'd you do 7 and 9? Oh! I'm
Because
stupid.
how much like Monday?
2
There's
times
2
4 minus
times,
1.
guys. I didn't
Okay.
know which one.
All right. Let's do the next one. Okay, on this
Yeah,
one,
there is.
let's get through this. Okay, we're going to start by plugging in a 1, then a 2, then a 3, then a 4, a 5, 6, and a, Dane, where are we going to stop?
7.
Stop when we plug in a 7. Now, I'm just writing there so everybody's clear what we're doing. This is going to be 3 times 1. First one's going to be a 3. 3 times 2. Next one's going to be a 6. 3 times 3. Next one's going to be a 9. It's just going to keep going by that. And because they're all positive, I'm going to stop when I get to, whoops, I'm dyslexic here, 21. So this is going to be 12, 15, 18, and 21. It's finite because we stop once we get to 7. Okay, now, on both of these, they've started at 1 and then they've stopped somewhere. So this is the expanded form for that particular sigma notation. Now we're going to take a look at this one. There's 2 things you should notice that are different about it. What do you notice? Wilson.
Lower limit is 0.
The lower limit is 0, so we start when we plug in 0. It's something else. It's infinite, so it goes on forever. And that's kind of nice because we can just set up the pattern. So here we go. We're going to do 2 to the 0, 2 to the first, 2 to the second, 2 to the third, and then the pattern's just going to continue. So this is sigma notation. This is not a sequence. So we're going to write down 1 plus 2 plus 4 plus 8 plus. We put the little ellipses, and there we go. Any questions?
9.
I like this.
Okay, you see how that one's the example that we did up above?
Yeah.
Okay, flip the page over.
Expand.
Okay, this one says expand and evaluate the sum. So if it's a series and it's finite, we can actually add them up. And sometimes, believe it or not, even if it's infinite, we can add them up. Now, I want you to notice there's a slight difference in this, and we use different typesetting to do these. On the ones up above, and I'm going to slide this down so we can see it, notice that that one, the k is the lower limit's off to the side and the upper limit's off to the side. Normally it's down below there and above there. It doesn't make any difference. You'll see it both ways. It just depends on the typesetting program that they use. So just realize that you're going to see those. So we want to find the sum for this. Now, because I wrote out all the work on the other ones, is everybody okay if on this one I plug in a 2, I get a 6, and I add 1, so the first one is a 7. Then I'm going to plug in a 3. So that's going to be 3 times 3 plus 1. That's going to be a 10. Plug in a 4. That's going to be a 12 plus 1, so that's going to be a 13. That's what I get when I plug in a 4. Then I plug in a 5, so that's going to be 16. And the last one is when I plug in a 6.
19.
So when I plug in a 6, I end up with a 19. Now, just to double check, hold on one second. I did a 2, a 3, a 4, a 5, and a 6. I actually have 5 terms in this expanded form of this series. Everybody clear where we got those? Dane, we clear where we got those?
Yes.
Okay, it says write it in expanded form and evaluate each sum. So you can do this on a calculator, or this one you can probably do by hand. Those add up to 17 and another 13. Those would add to 30. And these two add to 35. So if you add all those together, you get 65. So there are 2 parts to this answer. One part is the expanded form, and the other part is what's the actual sum for the series. Everybody good there? Okay, so we don't miss anything here. I'm going to do 3 to the second, 3 to the third, 3 to the fourth, 3 to the fifth. I've plugged everything in. We're going to write down what they are as just simplified numbers. 9, 27, 81, and correct me if I'm wrong, 243. I'm going to have to grab a calculator on that one.
Dang it.
Okay?
I got it.
So throw that in your calculator. I think we get an interesting number on this one.
357. 357.
What'd you get?
357.
What? 360.
What?
What is it?
360.
360? Somebody want to confirm that?
Oh.
Yeah,
I put in the 6 and the 7.
it's 360. So 2 parts to the answer. The expanded form for the series and what the sum of the series is. This sum right here is going to be a big deal when we do the stuff tomorrow. Okay, any questions? All right.
Oh.
Okay, listen carefully. We're going to do one more hard thing, and then we're going to make it super easy. Okay?
I skipped.
Hang on. Okay, so here's the deal. This says write each series using sigma notation and start the index at k equals 1. So for each one of these, we've got to figure out what the formula is in order to write this down. So this is A1, A2, A3. I'm going to do sigma notation. We're always going to start this at k equals 1. And we want to figure out how many we've got here. So we have to figure out the formula and where we need to start and stop the index. So let's see. Gavin, arithmetic or geometric? Arithmetic. Common difference? 3. So the nth term formula is going to be the first one plus n minus 1 common differences. So if I simplify this, There's the formula.
That's a really hard one.
Oh.
Hang on 1 second. So when I come over here, I'm using a different index. We usually use n's for sequences and we use k for series. So I'm going to write 3k over here, and then I need the upper limit. I need to know where it stops. We stop when we get to 24, but what index, what counter do we plug in to get a 24? Luke? 8. That right there's the answer.
That's not that hard.
Yeah.
Can't you find the upper limit by dividing the biggest one by?
You'd want to be a little bit careful on that because sometimes the formulas are a little harder. Yes, on this one you just divide by 3. Luke?
So what are you supposed to do for the variable again? Does it matter?
Use k for, usually we use k for series and we use n for sequences.
I'm gonna use J for
Alright.
Jack.
Okay? People do use j. Okay, take a look at this one.
Jackie Grill.
D. Arithmetic or geometric? Arithmetic. Common difference? Very good. Common difference is -6. So the nth term formula is going to be the first one, plus n minus 1 common differences of -6. Please be super careful when you've got a negative difference. Make sure you're distributing it through the right way. If you don't, you're going to get the wrong answer. So this is going to be 9 minus 6n plus 6. So this is going to be -6n plus 15. Am I right?
The other way.
Yeah.
You are right.
K equals, we're going to start at 1, and it's going to be -6k plus 15. This one's kind of cool. What is it?
Infinite.
We stop at infinity because we've got that ellipses. So there's the work that we have to do to find the formula, and then because this is infinite, we just put infinity as the upper limit. Okay, any questions there?
Would that be the lower limit?
The lower limit is
Negative.
1. No. Okay, we're talking about the
Dang it.
index. Okay. Do the next one.
Bet.
Do the next one.
16.
But that's geometric.
Do the next one.
Ratio of
Okay.
16, so that's a lot of numbers.
Oh, just do it. Come on.
What's 16 divided by 4?
4.
4.
I forgot the formula.
That's a good. Yeah.
It's 7.
Yeah.
Wait, really?
4 times
So it's just 4n.
the R.
4 times 4 and times 4.
You're wrong, Drew.
-1.
Yeah, that's 4.
I'm gonna do it my cool way of like going like.
Times 1, 4, and that's gonna like cancel that. So it's 4.
Wait, what? No, that's not right.
Yes, it is.
So that like 20.
I'm not talking to you. How do I find the upper limit?
Think about it.
What if I do it in
Answer equals 1 for
square root
n.
No.
4 to the. I'm gonna just guess. Is that what you're supposed to do?
Guess you should.
4 to the 9th.
Do that. What is this?
Wait.
No, that's wrong. Yes.
But like,
Yes.
But how do we get that normally?
So you put 7.
No, but other than guessing.
I got it.
Yeah.
You don't. You just guess.
Okay.
or you could just do the math.
No, but
How do you do the math?
Wait, for which
Just
one?
guess.
we have
Yeah. See.
For which one?
Okay, Lizzie, do you have the explicit formula for us? 4 to the
Yes.
R.
4 to the n or 4 to the k, either one. We're going to start at 1. That would work. And then if you'll take a look here, for right now, the only tool we have for figuring out which one we'd be on, because you're basically solving this right here. I mentioned last week, if you've got a variable up in the exponent, we don't have very many tools for working with this. One thing you could do is you could put this in as y1, this in as y2, and have the calculator intersect and find where it is. The other way is to guess. Next year, you're going to learn about something called a logarithm that will allow you to actually take that down and then solve for that. But for right now, we just say, hey, the upper limit on this one is 7.
So the thing I was talking about with A only works on arithmetic.
And even if and only if they're really simple. Yeah.
Really?
Uh-huh. Yep. Okay, slide over. Let's take a look at this one. Abby, arithmetic or geometric? It is geometric. Anybody know what the ratio is?
1/2.
Right.
What is it?
1/2.
It's 1/2. There's a couple different ways you can figure that out. Take any one of these and divide it by the one before it. So if I took 5/8 and divided by 5/4, 4 on the top, 5 on the bottom, those would cancel. We'd end up with a 1/2. The other thing you can notice is that every single time we're multiplying the top by 1 and we're multiplying the bottom by 2. If you multiply the top by 1 and multiply the bottom by 2, you're multiplying by 1/2. Okay? So we're going to start out with k equals 1. And then there is a quick way that you can figure it out if you can catch on to this. To go from one to the next, we multiply by 1/2. What would the opposite of multiplying by 1/2 if we wanted to back up one? Divide by 1/2, or that would be the same as multiplying by 2. So if you double check the math, and I urge you to go through and do this, you'd get that as the formula for the sequence. And then which one are we on? This is the first one, second one, third one. 32 would be the fourth one. This would be the fifth one. We're going to stop right here at 5. Okay, any questions?
Perfect.
All right. Okay. Now, whoops, get this out of here.
Calculator.
Yeah, grab your calculator.
What do you need to use your calculator for?
Okay, I'm going to show you if you have a problem like this. You have 3 problems where you write it in expanded form. You have, 6 problems. 6 problems where you write it in expanded form. 6 problems where you write it in sigma notation. And 6 problems where you literally just get to pop it in your calculator. So I'm going to show you the steps that we're going to use for this. So the first thing we're going to do is we're going to clear off the home screen. So go ahead and do that. And we're going to do this problem right here. So we want to find a sum. So hit second and stat. Second and stat, that brings up the list menu. We're going to go to math. And number 5 on math is the sum. We just have to tell it what to sum. What we're going to sum is a sequence of numbers. So hit second and stat again. And instead of going to math, go to ops.
Sum ops.
Ops is the middle one right there. And again, it's number 5. So grab number 5. Now, depending on the calculator you have, it might look like this. Okay? So we're going to type in the expression. The expression on this one is 2, hit the variable key, minus 3. So 2x minus 3. We're just changing from k's to x's. Tell it that the variable is x. If you want to use alpha and do k every time, that's totally okay. Tell it where you want to start. The lower index is 5. You want to end when you get to 20. And the step is 1. The step is always going to be 1 unless you're told otherwise. Now, if you have this type of operating system and it's doing this, you can follow right along. When you get to the bottom, it's going to say paste. I'm actually not a huge fan of this, but that's totally okay. It's going to paste this in here, and I've got a little picture right here of what it should look like. Now, it doesn't all fit on your screen unless you've got a really high resolution, but this is what it should look like. Okay, so I'm going to zoom in just a little bit. Okay. Hit enter. It'll tell you the answer's 352. Did you get 352?
Yes.
Mason.
So if you go to math
I did
and then
not
hit the
do
0
52.
key, guess what happens? This is crazy. Go
What
to
the-
math and hit 0, it gives you the sum.
That's so much easier, bro.
Oh, very cool. Okay.
It gives you this thing.
Wait, why did
Okay.
mine get negative 1200?
Didn't know that.
tell you.
Didn't know that.
Why did mine get
Okay.
negative 1200?
Should we try it?
Yes.
Okay, here's the only problem. I don't think everybody has a calculator with this operating system on it.
We do.
Okay? Hold on, that's fine. So if you don't, listen up. If you don't, this is what you're going to use. Okay, now, if you have one of these and you can hit math and 0, I'm going to put in an X because that's easy to do. I don't have to hit alpha. I'm going to put in a 4. I'm going to come up here. I'm going to put in a 42. And then we're going to do negative 4x plus 5. Hop over here. And I do like this. I tell my basic students, I say, hey, make sure that whatever is on your screen matches what's on your paper. And then you don't have to make any mistakes or wonder where your mistake is. We hit enter and we get negative 3393. Now,
Thank you, Mason.
nice job, Mason. Okay? Okay. If you don't, so hold on. I'm going to pass out today's assignment. If you don't have that operating system, you're stuck doing it the other way. If you do have that operating system, which, here's my problem with that. I could teach a third grader to do that.
Exactly.
Well, that's why it's on the calculator.
You must be a pretty great teacher, Mr. Laws.
Yeah, amazing.
Wait.
Okay. Cross off. Nope. Cross off multiples of 5.
Yes. Yes. Thank you.
Oh, you're very welcome.
4 would have gave us.
Cross up 19 also, or just use it for bonus.
No.
Yeah.
No. No.